Okay, so we're going to do a pretty I don't know, elaborate topic now called combustion analysis. And this is really cool, but there's several steps to it. So let's read it. 8 grams of a certain compound X, known to be made of carbon, hydrogen, and maybe oxygen, and has a molecular mass of 160, is burned completely in oxygen, and the mass of the products are carefully measured. Alright, so I've set this up over on my whiteboard already. Let's go over there now. Same problem, as you can see. And we're going to really depend heavily on some concepts that we have learned in previous topics. And one of them is that whatever this is, let's say CXHYOZ, where Z may be 0, 1, 2, because we're not even sure it has oxygen in it, right? Plus oxygen is going to give us carbon dioxide and water, right? All right, so what we're relying very heavily on is this. If this is 1, then that X is 1, right? And if this is 1, or rather, let me say, if this is 2, can you see 2 times, if there's 2 moles of water, what is Y? Look at that. If there's 2 moles of water, 2 moles of H2O, what is Y? Y is 4. Can you see that? That would mean there would be 4 moles of hydrogen over here if we have 2 moles of water, okay? Now the oxygen, we don't know what that is going to be, because there's several. Look, they all have oxygen in them, right? That's got oxygen, maybe. That definitely has oxygen. This has oxygen. That has oxygen. So we're going to rely really heavily on that principle right there, that all the carbon that is here comes from that right there. And this hydrogen all comes from here, right? But there's double of it, okay? So with that principle in mind, I'm gonna shut this down and go to another layer, open this one up, and we're gonna set up a table for ourselves. And it's a big elaborate table. CX HYO, I'm gonna say Z plus oxygen gives carbon dioxide and water. I'm also going to say, I want to know how many moles of carbon are in it. I'm going to set up more things over here, and how many moles of hydrogen and how many moles of oxygen. Or in other words, here's our table: mass, formula, weight, and moles. And this will be in grams. This will be in grams per mole, and this will be in moles. Okay. So you know that if I get the mass of all 3 of these together, it's going to equal the mass of this, right? Okay, that's why I want to set these other columns up as well, okay? So let's go back over here now and see that the mass was total of 8 grams. This was 8. The formula weight was 160. Okay, now if I wasn't thinking real clearly, I would just go ahead and figure out how many moles I had of this. I don't think I'm going to need that right now. But you see that number just comes tumbling automatically out of these two, right? Grams and grams per mole is going to give me moles. I don't know how much oxygen was used. That's completely unknown, right? Because it says enough oxygen, okay? But we do know how much carbon dioxide was there. How much was it? We made 13.2. Can you see it right here? 13.2 grams of carbon dioxide. And how many grams of water? 3.6. Right? And look at this now. We know this is 44.01 grams per mole. This is 18.02 grams per mole. And so we know now how many moles of carbon came out of this this compound. How many moles of carbon came out of that? It's going to be 13.2 divided by 44.01. 13.2 divided by 44.01 gives me 0.299999. 0.2999. 4 nines, no, 3 nines. Okay. And then how many moles of water? 3.6 divided by 18.02 gives me 0.1998. 0.1998, right? That's how many moles of water and how many moles of carbon dioxide. Now, if I know how many moles of carbon dioxide, and I know how many moles of carbon, right? Because it's 1 to 1. 0.2999, right? And if I know how many moles of water, I know how many moles of hydrogen, right? Because there's 2 moles of that for every mole of hydrogen, right? So it's going to be that times 2, 0.3996. Okay? Now I know what mass I have of carbon, because carbon's 12.011 grams per mole, and this is 1.008, right? So times 1.008 equals, this is going to tell me how much mass I had of it, and it's, I'm going to do this in a different color. I'll make it black. This is 8, we had 8.0 grams total, right? And 0.4 of it, 0.28, was hydrogen. How much was carbon? It was 0.2999 times 12.011 equals 3.602. 3.602, right? And so we know that 8 is equal to 3.602. That's the mass of carbon plus the mass of hydrogen, which was 0.4028, plus the mass of oxygen, right? Because that's all it had in it. Okay, so plus 0.4028 equals, subtract that from 8, equals 8.4. Is that right? Just a second, that doesn't seem right. That's not right. Just 1 second. 8 minus 3.602 minus 0.4028 equals 3.9952. 3.9952, right? 3.9952. Now I know how many moles of oxygen were in there. Right? Can you see how this is just a big game of going back and forth between moles? This is one rule I had to know, that the mass of all of them were equal. And I also have to know that the moles, I have to know these things here, right? Okay, so let's go and find out how many moles of oxygen there were there. 3.99 divided by 16 equals 0.2497. 0.2497, okay? So the empirical formula is C, 0.2999, H, 0.3996, O, 0.2497. Okay, now obviously you don't have empirical formulas like that, so we're going to divide everything by the lowest number here, 2497, right? Its ratio is really 0.2497, 0.2497, and this is going to give me C, H, O, and there's a 1 there, I can see that one. But let me say 0.3 divided by 2.5, or 0.3 divided by 0.25 equals 1.2. 0.4 divided by 0.25 is equal to 1.6. Okay, so this looks like a fifth right there, so I think if I multiply everything by 5, I'm good. Okay, so this is going to be C5, or rather, just a second here, C6. And what's 1.6 times 5? Times 5 is equal to, that should have been obvious to me, C6H8O5. All right, you see why I did that? Because these have to be ratios. Okay, now I'm a little bit, this is getting a little bit busy. I'm gonna open up a new layer and get rid of this. I see it's C6H5O8, right? Let's go back to black. C6H, no, that's not right. C6H8, I think it was, right? H8. C6H8O5, right? And so I'm going to say, let's find out the formula weight of this thing first. It's 6 times C plus 8 times hydrogen plus 5 times oxygen, which is equal to 6 times 12 plus 8 times 1 plus 5 times 16 which is equal to 72 plus 8 plus 80, which is equal to 160. Aha! 160. So this is my empirical formula, because that's the formula way to that. So let's go back over here, come back here and say it's, uh-oh, I lost it. It was C6H805, C6H805. Wait, 5. Okay. All right, let's check that guy. All right, let's do one more. It's going to make for a really long video, but I want you to have the extra practice, okay? So let's do another one. Now it's obviously the same principle. Let me snapshot this real quickly here. Come back over here. Get rid of this. Do you want to save changes? No, I don't. Let's open this guy up again. Get rid of that. File, add image. Come down here. Combustion analysis, okay. All right, let's do the same thing. Now, don't forget the two principles that we're assuming is CXHYOZ plus O2 is going to give me X carbon dioxide plus Y waters, right? That's the one. And then the other one is the mass of CXHYOZ is equal to the mass of carbon plus the mass of hydrogen plus the mass of oxygen, right? Those are the two principles I'm invoking here. Okay? So let's go on now to the next page. Let's go here and let's disappear as 4. I think I can see that, okay? So let's, uh-oh, I lost something? Yeah, okay. Okay, so let's go here and say CXHYOZ plus oxygen gives me carbon dioxide plus water. I'm going to make another column for carbon, hydrogen, and oxygen here. Okay, mass, formula, weight, and moles. This is in grams. This is in grams per mole. This is in moles. Okay. So now we're going to come back over here. It was 4 grams of a certain compound. So this was 4 grams. Okay. What am I doing here? Gives me 5.87 grams of carbon dioxide. Where's that? 5.87 grams of carbon dioxide and 2.4 grams of water. 2.4 grams of water, right? Let's get these formula weights. This was 44.01. This is 18.02. And so that's going to give me how many moles of carbon dioxide? Let's go. 5.87 divided by 44.01 equals 1.333. 1.333. Really 1.334, I guess. I didn't round that right. Okay. Excuse me. And let's do this. 2.4 divided by 18.02 equals 1.332. 1.332. This is too convenient, isn't it? Okay. So the moles of carbon then is the same as the moles of carbon dioxide because it's a 1-to-1 ratio, 1.33. I'm going to change this to the number it really was in my calculator, 0.334. It's really supposed to be 4. And this one is going to be double that, 1.332. Let's see, times 2 equals 2.664. 2.664, right? And this formula weight is 12.011. This formula weight is 1.008. So let's go back to red over here. That's going to give me 2.664 times 1.008. It's going to give me 0.2685 grams, 0.2685 grams of hydrogen. How many grams of carbon? 1.334 times 12.011 equals 16.02 16.02. No, that's not possible. I did something wrong here. I did something wrong. I can't have more carbon, right? I got 16, and it can't be 16. So I have a mistake here somewhere. 5.87, just me here. 5.87 divided by 44.01, 0.13. Ah, it's not 1.33, it's 0.133. Okay, sorry. Times 12.011 is 1.6. I was getting 16 grams here, and I knew that couldn't be right because I only started with 4, right? If I start with 4, it's going to be 4 is equal to 1.602 plus 0.2685 plus the amount of oxygen I got, right? Well, I couldn't have 16 over here. That wouldn't make any sense. All right, so let's go here. Plus 0.2685. Subtract that from 4. Equals 4.269. Oops, just a second here. 4.2. No, that cannot be right. Can't be more than 4, right? Man, I'm just having some trouble here. Okay, let's start over again. 4 minus 1.602 minus 0.2685 equals 2.130. 2.130. Okay, so 2.130, and the formula weight of oxygen is 16, right? So now we know how many moles there were. Divided by 16 was 0.133. 0.133. Wow, this is too convenient. So it looks like it's C. 0.1334 H 2.6. It's not 2 points, 0.2. This is another mistake. Look at that. Man, I'm telling you. It's not that. It's right here. It's 0.266. For an oxygen, 0.133. Okay, so we divide all by the smallest number. We get C1 H2O1 or CH2O. Okay, now I'm going to go to a new layer because I'm getting confused here. CH2O. CH2O is going to be 1 times carbon plus 2 times hydrogen plus 1 times oxygen, which is equal to 1 times 12.011 plus 2 times 1 plus 1 times 16, which is equal to 12 plus 2 plus 16, which is equal to 14 plus 16, which is equal to 30. Okay, so it's 30. Now I'm going to go back to my original question and find that the grams per mole was 150, right? So let's go here. N times 30 is equal to 150. N must equal 5. So this times 5 is equal to C5 H10O5. Okay? Do you see that? To prove it to myself, I did that last step a little bit fast, okay? To prove it to myself, I'm going to say, all right, well, let's calculate it. 5 times 12 plus 10 times 1 plus 5 times 16 is equal to 60, plus 10 plus 5 times 16 is 80, which is equal to 70 plus 80, which is equal to 150. All right, and that is what I'm looking for. So let's get rid of that, come back on here, and you see it's 150. 150 grams per mole. Okay, so let's go back over to it. What was it? C. Uh-oh, I forgot now. I already forgot. How could I do that? C5H10O5. Let's come back over here. C5 5H10O5. 10O5. Okay. All right, give me some green. All right, very good. Okay, so that's all I'm going to do for this video. I've got to do one more before I get to move on to my next topic, but hope that's helpful.